Alright, so now that I've gained access to the inside of this thing, I'll point out the different sections. Here we have the master oscillator and top octave generator, which is sent to the divider board. These two boards together are what generate the raw waveforms, which are distributed all the way across the keyboard. Underneath the control panel we have some preamp and tone filter circuitry. Then underneath that we have the power supply, which is in a steel enclosure. Over here we have the phaser board, which I'm told is a copy of the electroharmonic small stone. I'm not really sure what this is. I think it's some kind of tone filter or preamp, maybe for the bass section. And of course we have this giant circuit board which runs the entire length of the keyboard. This is what contains the key switches and the envelope shaper circuits for each individual note. So I've zoomed in on one of the defective notes. This is the lowest B note. It just doesn't make any sound when you press it. Before I actually start working on any of the circuitry in here, I'd like to determine that this note's raw waveform is actually getting to its respective circuitry in the first place. That's what this brown wire here is. This is the input for this note's raw, unfiltered pulse wave that's coming from the divider section. I have a small guitar amplifier on my bench that has an instrument cable that has some alligator clips on one end. This is a 100K resistor there to protect my amplifier in case I accidentally touch the power rails or something like that. So I should be able to hear this low B's waveform, raw waveform, when I probe this point. There it is. So we know that the waveform's getting there just fine, so now we can proceed with troubleshooting the rest of the circuit here. So I know from the schematic that this dark blue 10 microfarad capacitor is charged up when the key is in its resting position through this 28 volt rail here that goes along the length of the keyboard. When the key is pressed, the capacitor is switched into the VCA circuit and it's rapidly discharged and the volume of the note decays accordingly. And this can actually be seen if you hook up an LED to the switch contact of a note that you know that does work. So this is the next note up, a C. So we'll see what happens when I press that. You can see the pulse going through the LED as well. When we switch it into switch this onto the key that we know that does not work, you don't see anything. That's not too surprising. Now, this little test that I did with the LED doesn't necessarily indicate that this electrolytic capacitor is defective. However, given the fact that capacitors this old are so prone to failure, I think that's good enough evidence for me, so I'm just going to go ahead and replace it, and we'll see if that fixes this note. Looks like it works. This capacitor was, in fact, defective. You might notice that I used a radial capacitor instead of an axial one. That's just because I didn't have an axial capacitor of the same value in stock. You can see I did it on this, this note here too. One of the more difficult things about working on these keyboards is it's really, really difficult to access the back of the keyboard. You have to unscrew all these screws along the keyboard and then remove these spring contacts from the keys. So the only way around that is by clipping off the old components, leaving as much of the original leg on as possible, and then you can use those to wrap around the new components' legs and then solder them in place.